All right, bunch of examples and notations for the power rule, section 2.2. So let's just kind of zip through them for a moment here. We learned before that here's the basic power rule that I just take n, I multiply it by the coefficient, and then I drop the power by 1. So looking at that real quick, 3x squared, the derivative also can be noted. If this is y equals 3x to the 6th, then the y prime is 18x to the 5th. All right, same kind of token, but also let's go back up here and notice one time that if you basically just want the derivative of two things being added, then you just find out two things being added. Please understand this minus sign did not come from me flipping the sign or anything crazy like that. The derivative of cosine is negative sine x. Right there it is, still up on your paper. So I could have put plus a negative sine x, maybe if that would have been more clear. My head already just turned it into a subtraction sign. This normally would be a positive down here. The only reason it's negative is because the derivative of cosine is a negative sine x. Okay, 2 times 2 is 4. Drop the power to 1. You don't really write it. So what if you have a monomial divisor? You split it up, 2x over x, x squared over x. You simplify it, 2 plus x, you take the derivative. The derivative is equal to 1. I could work this out a little farther, but let's just go as simple as possible. 2 plus x is a linear function. In a linear function, the slope anywhere on the line is the coefficient of x. The coefficient of x is 1 pow. There it is. Okay. Now, what happens if I've got a power in the denominator? If I go rewrite x to the negative 3 power, all right, take the derivative with respect to x, d dx, that's a notation. What do you get? Negative 3x to the, oh, it's a negative 4. Please drop that power by moving it to the left on that number line I talked about. You'll make this mistake, and I'll go, look, I told you, write the number line down. Okay, so we could rewrite it again as negative 3 over x to the 4th if we feel like it, because that's proper form of why this x is negative 4 exponent. Let's go down and look at another monomial divisor. We got 3x plus x squared over x to the 4th. We can again split it. We can again simplify it. We can rewrite it with the negative exponents in the numerators here, and then we can do the power rule. Negative 3 times 3 is negative 9. Drop this by 1, you get negative 4. Negative 2 times 1 is negative 2. Drop that, you get negative 3. Rewrite negative 9 over x to the 4th plus negative 2 over x cubed. I won't ask you this, but it's possible that a multiple choice test might put it back in the bit with it's only got one denominator. So you'd have to multiply both the top and the bottom of the numerator and the denominator of this second function by x so that it had a common denominator. And this is y prime. Again, what does y prime mean? It means rate of change of the original function. What does y prime mean? It means tangent slope of the original function. Okay, we are finding a value which is the slope of the original function, also known as the rate of change. Last but not least, what if we want to find the equation of a tangent line? We're going to pick the graph, f of x equals sine x. We're going to pick the x value, x is equal to pi over 3. So the first of all, to find the equation of a tangent line, we need a point on the tangent line, and we need the slope of the tangent line. So let's tackle the point first because it's the easier of the two. A point is simply plugging the x value, x is equal to pi over 3, into the original function to get a y value. As we see from over here in the graph, the sine of pi over 3 is equal to 1/2. So the point is pi over 3 and the y value is 1/2. So pi over 3 comma 1/2 is a point on the graph. How do we find the slope at pi over 3? We plug pi over 3 into the derivative. So first we take the derivative. The derivative is negative cosine x. We showed that above once. So if I plug pi over 3 in the derivative, pi over 3, the cosine of x is rad 3 over 2. And if I make it negative, I got negative rad 3 over 2. This is the slope. So now hopefully we remember point slope form. We went over this, I think, about a video ago. Y minus y equals slope times x minus the x. Point slope form, this would be y minus 1/2. This is the y value from up here, equals slope, the slope from the derivative evaluated at that point, times the quantity x minus the x value. And again, this is the x value from the point on the graph. This gives us the equation of the tangent line. And that's what we got for you today. Thanks.